We've got a big update, a huge update on our favorite interstellar object. It could be the biggest update in the solar system. Take a look at this. This is 3I Atlas. You know how the last time we talked about it, it went behind the sun, then it got brighter, then it got bluer, then it started to go faster, non-gravitational acceleration? Well, guess what? We just got new images of it, and to add some more strangeness to the 3I Atlas saga, because, I don't want to overhype this, but yeah, you see, that's a comet. It does not have a very big, very noticeable cometary tail.
Okay, take a look at this. The New York Post saying that U.S. Representative Anna Paulina Luna is calling on NASA to share unreleased photos of the 3I Atlas comet as it appears to have shifted colors for a third time. NASA discovered the interstellar comet, and it's of course, fascinating because it's an interstellar object that has wandered into our backyard. The space agency spotting the quick-moving object with the Atlas telescope in Chile over the summer, and then it confirmed that it was a comet from another star system shortly after. It's officially the third ever known interstellar object to pass through our solar system, and it poses no threat to Earth. Some online conspiracy theories and even a few scientists have suggested that 3I Atlas might be an artificial object or even a probe from another civilization because of its strange chemical makeup and trajectory. Ken Gailey is standing by. He's an astronomy professor at the University of Iowa. Ken, little green men with big eyes and flying saucers, all but confirmed now, correct?
Well, probably not, but I mean, it's exciting. These comets are very exciting because they're coming from outside our solar system. So anytime an object is coming to us from outside the solar system, it's going to stimulate some great interest. And some of that interest will be more on the science fiction-y side and some more on the science side. And it's never completely obvious where to draw that line. Science has to take its course. But we would always start off with the assumption that these are natural objects, and we would study them in that way. And if there's really very powerful evidence that they're not, then we might be led toward another direction. But for now, there's still plenty of evidence that these are potentially just completely natural objects. So let's start with understanding what a comet is in the first place, because comets are quite normal. We've seen many comets in our own solar system. They're big, giant balls of ice, and typically water ice, but some carbon dioxide ice and carbon monoxide ice is in there as well. And when they get close to the sun, they evaporate some of this ice. And there's dust trapped in the ice, which then leaves the comet, and it reflects sunlight. And then the sunlight that it's reflecting actually pushes on the dust and pulls it out into a beautiful tail. So comets are quite pretty, and they tell us a lot about our own solar system. But these three comets that you talked about are all from outside our solar system.
Professor, the last time we spoke, which was like the day before yesterday, you were saying that when it went behind the sun, the natural explanation for the non-gravitational acceleration and the thrust might be because it burned off a bunch of chemicals or something, and that was giving it the thrust to the tune of like 13%, and we would see a humongous tail maybe. What is going on?
Yeah, that's very surprising because there should have been a very massive cloud of gas and dust around it based on what we know about comets. In fact, we see other comets in the solar system that have a beautiful tail away from the sun. Behind them, Lemon is an excellent example. But in our case of 3I Atlas, it looks like a fuzzy ball of light. Even after it passed through perihelion, it was heated by 770 watts per square meter. And we know that the previous plume of gas was mostly carbon dioxide. And carbon dioxide ices can sublimate at a much lower temperature than water ice. So we should have seen it break up, or at the very least disintegrate to a very dense and massive cloud of gas and dust that is pushed away from the sun by the solar radiation and the solar wind. But we don't see that. So the question is, what's going on? One possibility is that what evaporates from it are fragments of ice, and they get vaporized by sunlight before they have a chance to turn around and show up as a plume of glow behind it, away from the sun. That's one possible interpretation, but otherwise I just don't know what to make of it. There was also a blue color that was noticed just a few days ago, and also in addition to that, it became brighter by a factor of 5. So what I'm saying is, you know, there are things we don't fully understand about this object. That's what makes it exciting.
Let's satisfy the appetite of the people who think this could be a artificial object, if you will. What type of evidence would be necessary to prove that it were an artificial object, to actually take something like that seriously?
Right. Well, that's a very interesting question, because let's start with Oumuamua. That one, you would expect if it was an artificial object, it might have some ability to generate thrust on its own. But the problem is comets can generate thrust on their own because of this evaporating ice that comes off it. It only comes off on the side that's facing the sun. So it's a push. As this stuff evaporates, it pushes the comet. And so you can see a trajectory that's not completely natural under the gravity of the sun. But it is natural in the sense that it's still coming from this push from the evaporating stuff. Now, Oumuamua, we couldn't see the evaporating stuff coming off it, and yet it was getting a push anyway. So that's what made it quite interesting from the point of view of possibly being some kind of a spacecraft, because it was getting a push. But the push it was getting is consistent with other kinds of ices that we can't see as easily when they evaporate. And these other kinds of ices would be fascinating from the point of view of where this comet formed and what kind of conditions it formed under. Now, the last 2 comets that we've seen, we could see the stuff that was evaporating, so we understand the push that they're getting. But they're different too, because Oumuamua was very long and skinny, which also kind of conjured the sense of a rocket or something. But the next 2 were not that way. They're more normally shaped. But this 3I Atlas that you're talking about is very weird, because its outside layer is mostly carbon dioxide, which is dry ice. So that's what you see in parties. It's very cold. It makes that misty stuff coming off. That's mostly what the outside of 3I Atlas is. And that's very unusual for it to be that pure carbon dioxide. We don't see that in our own solar system. But you have to remember that these comets have been outside of any star system for billions of years. And as a result, they've been getting hit by what's out there in the galaxy, which is something called cosmic rays, which are very high energy particles that crash into everything out there. We're protected from this by our sun's magnetic field and solar wind. But the comets out there are getting hit by these cosmic rays, and that's what can cause the carbon monoxide and H2O to turn into carbon dioxide. So it's natural that the outside layer could have gotten very heavily processed. But it's still, even if you undo that processing, it still is weird what its composition is made of. So it probably formed from a very different kind of star than the sun.
Representative Anna Paulina Luna sending this out earlier today, saying she just had a good conversation with NASA regarding 3I Atlas. As soon as the government reopens, they'll be releasing images and data of it. She says that NASA has also noted, she says she's sure that it'll be one of many interstellar objects that we will be able to track now that technology has advanced. My question for you, Ken, what do we stand to learn from an object like 3I Atlas? What can it teach us about areas that are far, far away?
Well, that's a great question, because the answer is we don't know until we find out what it has to tell us. Because science is about unraveling the stories of nature, and these objects from outside our solar system have a story to tell that we don't know yet what that story is.
And I think all of us will wait for the data that will come in the coming weeks, and especially on December 19th, when it comes closest to Earth. That's 6 days before Christmas, and let's hope we don't get unwanted gifts for our holidays.
Or at least maybe those gifts will be nice and friendly and wonderful and help us figure the universe out. We'll see. Avi, you do not seem surprised here. I know that we've been asking you about this, and we were all expecting to see a tail, and we asked you for a natural, plausible explanation. You gave us that one, and now we're saying no tail. Like, what do you think it is?
I don't know. I think... it's like a blind date with an interstellar object that came from an environment that is alien to us, and I think the key question is whether it's natural or technological. The secondary question, if it's natural, what kind of an environment did it come from? It must be a common environment that produces large packages delivered to our mailbox, and we just need to find out the sender. Either way, it's thrilling, and it's really the reason why science is worthwhile doing, because we can gain new knowledge, and that goes against the tendency of experts to pretend to be the adults in the room that know the answer in advance. Well, guess what? This object is telling the experts, think twice.
Well, unlike 3i Atlas, this tale is far from over, and we will be dialing you up every twist and turn.